Supernetting. Before we get into supernetting, let us understand what is the basic difference between supernetting and subnetting. Supernetting is the opposite of subnetting. In subnetting, a single big network is divided into multiple smaller subnetworks, whereas in supernetting, multiple networks are combined into a bigger network termed as a supernetwork or supernet. Supernetting is the procedure of combining multiple subnetworks into one network. The process of supernetting is just the inverse of subnetting. In the process of supernetting, bits of the networks are converted into bits of the host. Other names for supernetting are aggregation and root summarization. This process enables the creation of more host addresses, and these host addresses are created at the expense of network addresses. Supernetting is performed by the Internet Service Provider for achieving the most efficient allocation of the IP address. Supernetting is performed for aggregating multiple networks into a single network. CIDR value, network ID, subnet mask, broadcast ID, and block size of every route are required for performing the supernetting. Classless inter-domain routing (CIDR) supported routing protocols are the requirement of supernetting. Contiguous, same size, divisibility are the three rules that must be satisfied for performing supernetting. One reason for doing supernetting is that to reduce the routing table size, so it's saving the memory. For supernetting, all the networks are to be required in the same class. Now let us see at the supernetting components. CIDR value, network ID, subnet mask, broadcast ID, and block size of every router is required for performing the supernetting. For checking the route alignment, network ID and broadcast ID is required, and for performing routes must be required to be sequential. Block size is required for calculation of the summarized route from the routes that are given. CIDR value and subnet mask are different notations of the similar thing, and both are used for finding out the number of network bits in the IP address. Now let us see some of the advantages of supernetting. Supernetting reduces and controls the traffic on the network. It also helps in solving lack of IP address problems. Routing table is minimized by the supernetting. By supernetting, entries of routing information are summarized into a single entry of routing table, which results in the decrement in the size of routing table. Hence, supernetting saves memory space. There are some disadvantages of supernetting, which are it will not be able to cover different areas of the network when several entries are merged. Another disadvantage is that all network must be in the same class and also every IP address needs to be contiguous. In supernetting, block combination must be in the power of 2 periodically. Suppose there is a requirement of 3 blocks, then 4 number of blocks will be assigned. Thank you.